Hi everyone, this is Jay, your instructor for computer networks, and in this session we are going to discuss the Ethernet. The Ethernet is a protocol for the local area network. So if you want to create a local area network, you should be following the Ethernet protocol. So for example, if you want to create a local area network, what things you need? You will need a device that you want to connect, you will need link, you will need connectors using which you can connect the devices into link, you will need the power source, you will need the type of the cable. There are so much that you can think of. So if you want to create local area network, there are many ways possible, but if you want to create the best and most efficient local area network, so in that case you want to follow the Ethernet. So in the Ethernet we will see that which type of device you should use, or which type of cable you should use, which type of connectors you should use, so that the local area network will be working at its best. So what is Ethernet? It was developed by IEEE and the project name was 802, and it is a standard for the local area network. Ethernet was created back in 1976 at Xerox Palo Alto Research Center, and Xerox was the first company which implemented the Ethernet. So there are so many protocols of Ethernet are there. The most famous is 802.3. There is 802.11, which is the local area network Wi-Fi. There is 802.4, which is for token bus. There is 802.2, which is logical link. So these are the protocol for the local area network. If you want to create local area network of Wi-Fi, so the protocol is 802.11. So 802 is the master project in which they have specified that if you want to create local area network, these are the steps that you need to follow, these are the procedures that you need to do. So where is the Ethernet is implemented? You can see that in the OSI there are 7 layers, and the bottom 2 layers are the physical layer and the data link layer. The data link layer is divided into 2 types, the MAC and the LLC. So Ethernet lies in both 2 layers, the physical layer and the data link layer. So let's see the type of the Ethernet. The Ethernet is divided into mainly 4 types. The first one is the standard Ethernet, using which you can achieve the speed of the 10 Mbps. After that there is a fast Ethernet, using which you can get speed up to 100 Mbps. After that there is a gigabit Ethernet, which provides speed up to 1 Gbps, and there is a 10 gigabit Ethernet, which provides the speed up to 10 Gbps. Let's discuss the standard Ethernet. So these are the implementation. The first is the 10BASE-5, and which is implemented in the bus and using thick coaxial cable. The second one is the 10BASE-2, which is also used to create the bus topology, and it can be used using the thin coaxial cable. So what is the difference between the thick and the thin coaxial cable? The thick coaxial cable, we cannot twist that cable as we can twist the table. The thick coaxial cable cannot be twisted as thin coaxial cable. After that, the bus topology, the 10BASE-T, it is also implemented in the star topology, and the last one is a 10BASE-F. It is a bus topology using the fiber optics. So what is the meaning of 10BASE-5? 10BASE-5 means the speed is the 10 Mbps and the maximum distance can be 500 meters. 10BASE-2 means speed is 10 Mbps and 200 meters. 10BASE-T means the twisted pair cable, and F, it means the coaxial cable. So you can see that the speed is 10 Mbps, 500 meter, and the base, it means the broadband digital communication. You can see that the bus topology is created. There are devices which are computers, there are some servers, and which are connected using the thick coaxial cable, right? And there are some reflectors at the end. Why there are reflectors? Because the signal will be reflected back from those devices. The thin coaxial cable, you can see that there is minor curvature in the thin coaxial cable. So you can bend the thin coaxial cable, but that is not possible in the thick coaxial cable. The difference is that the speed is 10 Mbps, which is same, but the distance is around 200 meter, or to be specific, it is 185 meter. So you cannot use this topology, you cannot use this implementation longer than 185 meters. Why? Because if you use, there is a possibility that the power of the signal will be attenuated. Again, communication is baseband. You can see that there are devices, there are some and the devices and the servers are connected. Now let's see the UTP, which is the 10 base T twisted pair, unshielded twisted pair. You can see that the topology which is implemented, it is the star topology. So in the star topology, all the devices are connected via a central hub using individual cables, right? In the twisted pair cable, all the cables are twisted together. So if the cables are twisted together, the noise which is added in the cable will be very less. So that is the advantage of the twisted pair cables. Then after the bus fiber, you can see that 10 base F, so it means 10 Mbps, the fiber is used, and the baseband communication, you can see that there are two cables which are used to connect devices. One cable is individually to send data and one cable is to receive data. There is a centralized device which is hub, there are some servers, and there are some devices. Now let's see the fast Ethernet, which is known as 802.3Z. The main three implementation of the fast Ethernet is a 100 base TX, 100 base FX, and 100 base T4. So 100 base TX means that 2 wires category, 5 UTP. These are the category, means category defines that how the cable can stand for noise, and how it can send data without the attenuation of the signal. Then after, there is a 2-wire fiber in the 100 base FX, and there is a 4-wire unshielded twisted pair cable which is 100 base T4. The last Ethernet standard is 802.3, which is also known as a gigabit Ethernet, and the implementation for the gigabit Ethernet are the 1000 base SX, which is a short wave fiber. So we are using fibers, right? Because fiber provides the speed in the gigabits. After that, the 1000 base LX, which is a 2-wire long wave fiber. Then after, there is a 1000 base CX, 2-wire copper, and the 1000 base T, which is 2-wire UTP. And this is it for the Ethernet, and this is it for today's session. Thank you so much.